Hi, everybody. My name is Juan. Thank you for being with us today, and welcome to this uh, secure private access webinar that we prepared for you. Okay, so a little bit of housekeeping. If you have issues during the session, please make sure to use the chat section, or you can send an email to cloudsecurity-csm@cisco.com. If you have questions during this session, you can also access the Q&A section at the bottom right side of your WebEx by the chat. If you click on the ellipsis, you will see the Q&A session. Don't wait until the end. As soon as you have a question, send it over. I have a team of specialists with me that are here to answer all of your questions. And lastly, the session will be recorded. You are going to get a copy of the session and everything we've discussed during it. This is the agenda for today. I'm going to do a quick introduction on the product, and then we're going to take a quick look at the packages. We'll see where Secure Access fits in your enterprise. There will be a small comparison between Secure Private Access and Secure Internet Access. Going forward with the presentation, we will focus only on Secure Private Access. We'll look at the new Cisco Secure Client module, Zero Trust. There's a brief overview of it. The SPA components, these are the elements that are required to configure a secure private access rule. And then we'll go through the configuration piece. At least the slide will show some of the elements of the configuration. And finally, we're going to jump into the demo. Today's session is a little bit longer than usual. This is because the demo covers a lot of topics. Security services is a key enabler for any organization's hybrid work strategy nowadays. Whether your applications are in private data centers, SaaS locations, peer-to-peer, it doesn't matter where you have your applications. We want to be the man in the middle and intercept the traffic to make sure all your resources are accessed in a secure manner. This is where we come in, and we inspect all the traffic to make sure everything is sanitized. We protect your resources. This is a quick comparison to the packages. There is a link in the web version. Again, you will get all these links at the end of the presentation. This is a snip of the chart that compares both licenses, Secure Access Essentials and Advantage. The screenshot lays out the differences between these two packages. For a better view, I recommend to check the link and look at the chart by yourself. It's actually bigger than this, but we just put the last piece of it that lays out, again, the differences in the packages. Where do we fit in your organization? We're a security facilitator. As stated, we act like a man in the middle, and our job is to police your traffic. Whether it's going to private applications or the internet, we want to be in the middle and make sure all your traffic is safe. We do that, or we achieve that, by a mix of technologies and engines that are in the cloud, such as SWG. If you have background with Umbrella, if you know the product, this is very similar. The functionality was brought over to Secure Access. We also have CASB, Zero Trust Network Access, Firewall as a Service, Remote Access VPN to the cloud, among other services as well. And again, the scope of all the solution is to protect both the public traffic and also your private traffic when it's destined to on-prem or private resources. We're going to look quickly at a comparison between secure private access versus secure internet access. The secure private access is a product that was designed to provide secure access to your internal resources. These are the resources that should not be accessed by the general public. And the secure internet access piece of the solution is similar to what Umbrella did for you. Again, the functionality was brought over to the secure access product. So it has basically the same features, just a few more. Okay, this is a flow, an overview flow of the secure private access. On the left side, we have where the traffic is going to potentially come from. We have multiple sources. You can install the Zero Trust Network Access module on a roaming device. Also, you can run the service or the traffic through a cloud using remote access VPN to the cloud. If you have an IKV2 capable device, you can also send your traffic via an IPsec tunnel. And we also support a clientless session, right, to access your resources on-prem. When the traffic comes in into our cloud, there's a unified policy. The traffic undergoes decryption, the cloud firewall, and the security rules. At the bottom, we have optional features, which are the posturing. We can also do IPS, step-up authentication. We configure the frequency of the authentication, and that's how we police your traffic. When the traffic leaves our data center in the cloud, we have two methods for the traffic to egress. If it's coming from the remote access VPN or an IKV2 IPsec tunnel, which you send it straight through your private resources. And if the traffic is coming from one of the modules, it will be sourced from a CGNet range. Let me check on the, let me see if I can change a setting here. I apologize for the, okay. That should sound a lot better right now. Please let me know in the chat. I apologize, all messages a little bit late. Okay, we can move on to the next slide that is going to show all the traffic, all the flows for the secure internet access. This is the flow that is destined. Thank you so much. Sorry about that, Jacob. Didn't notice your chat until late. Okay, this is how the traffic looks like when it's destined to the internet. Again, on the left side, we have the potential sources where the traffic is going to come from. You come from the Roman security module, which is similar to the software you install on your end devices when using Umbrella. You can also perform a full VPN tunnel to the cloud, sending both private traffic and public traffic. And also, if you have, again, an on-prem IKV2 capable device, you can configure an IPsec tunnel. When the traffic gets inside our cloud, it's going to go through the unified policy. The first layer of protection is DNS, and then the traffic goes through the firewall, decryption, and the secure web gateway. At the bottom, we have an optional but highly suggested to enable features such as DLP, IPS, malware, the sandboxing. And when the traffic goes out to the internet, we do NAT as a service. We provide a new source IP address. This is what the flow looks like for the public traffic. Going forward with the presentation, we'll continue to focus only on secure private access. The Zero Trust module. This is a new module for the Cisco Secure Client. On the screenshot shows what it looks like next to the Umbrella module. The Umbrella module should be more familiar, the Zero Trust. This is what it looks like. Once you install the client, it's just an additional piece of GUI. This offers client-based Zero Trust access to private resources. It uses a similar technology of what the Umbrella module uses. Configuration is fed to the Zero Trust access module. So when the computer produces traffic that is destined to corporate resources, the traffic will be redirected to the cloud, being completely seamless and transparent for the end user. How do you deploy the client? Well, you get the client from our Software Central. Once you get access to your Secure Access dashboard, there's a section to get it from there as well, or from the XDR dashboard. You deploy it along with the root certificate, and you do it as you regularly would. If you use Intune, PDQ, GPO, any software deployment solution that you use will also work. If you've seen or if you've used to deploy the client, you download the head-end zip file from one of our repositories. And inside the zip file, there will be one additional MSI, which is to install the ZTA module. Requirements: we need Trusted Platform Module 2.0 for the client to work in Windows PCs or secure enclave for Mac devices. This, however, is a very standard, is a common enterprise practice for corporate devices. The benefits: remote users can connect to a single private resource instead of the entire network. This is the difference between zero trust access and zero trust network access. The network access provide access to all the infrastructure, whereas zero trust access only allows specific ports. The job of the client is redirect the traffic to the cloud, and then we also have the secure access policy in place to police the traffic and make sure that it's allowed. You can enable posturing before accessing the resources. This is a configurable item in the dashboard. And this is not a replacement for Cisco Secure Client, AnyConnect, or the VPN module. It's just an additional solution where the remote access is not desired, is not used for any technical difficulty, or just by implementation design. This is what the client looks like as soon as it's installed on a computer. The end user has to click on enroll, and they will be SAML challenged. It will be required to configure SAML before the module is tested or functional. A browser will come up, the users authenticate, and then the client is going to go to the green checkbox, the screenshot that you saw a few slides ago, and then it's ready to work. There's also another flavor for the ZTA technology, which is to forward the traffic with the browser, so you don't need a client. If you work with contractors or temporary employees, you can configure zero trust access in a clientless mode where you can expose on-prem resources through a secure link in the cloud. You have to make sure these users that are accessing the resource are they can perform a SAML authentication, because this is what is used to protect your on-prem resources. Currently, at the time of the production of this presentation, it was limited to port TCP 80 and 443. You can ask in the chat. I believe there are a few more ports that are that can be sent to the cloud with the browser. We'll confirm that. Okay, components for secure private access. These are elements that are required to configure a rule. This is the list of elements. We'll explore one by one a little bit more in detail. We need a name of the role, a priority number. This is similar to an access list sequence number. The rules are sorted out from numerically, and they're checked from top to bottom. The source is where the traffic is coming from. It will be the leftmost column in the slides that demonstrated the flow of the architecture. The destination is the pre-registered private resources or applications you want to protect through the cloud. Optionally, you can configure posture profiles and enable IPS, and also configure SAML. For sources, we support Active Directory users and or groups. Additionally, when configure an IPsec tunnel to the cloud, we can use the tunnel itself as an identity or create internal networks, bind these internal networks to the tunnels, and then select the internal networks as identities. These are the three possibilities. For destinations, these are your private applications or the parts of your networks that you want to protect through the cloud. These applications are end services that run on premises or in a private cloud in any space. When adding the private resource, you have to configure, or you have to tell the dashboard if the resource is reachable via the ZTA client, the clientless method, both, also a site-to-site or remote access VPN. The posture profiles is an optional feature, but highly suggested. And there are three flavors that you can configure. There's a posture profile for ZTA client-based connections. Another one for clientless-based connection. This is more limited. Nonetheless, this is still very useful. And the one that offers more features or more items to configure will be the remote access VPN profile. In the next following slides, we're going to look at a few screenshots of what the rule configuration looks like. The rules work on a zero trust principle where the default rule is set to deny all the traffic. This is a behavior that cannot be changed. So anything that you want to allow to secure access must be explicitly configured. You have to have a rule to allow the traffic. This is a snip of the dashboard. On the left-hand side, you hover over the menu on the left side on the secure and then click on access policy. You are then brought to the access policy configuration, click on access rule, and in this case, you click on private access. The next slide shows the entire configuration of the first part of the policy. So from top to bottom, you provide a rule name, the rule order. This is the sequence number. Where do you want to place this rule in the list of rules? The action is whether the rule is going to allow or block the traffic. The from box, this is where you call where the traffic is going to come from. The to box is where you call your already or previously registered private resources. You can configure a posture profile on step number 5 for client-based connections. Step number 6 is a profile for clientless-based connections. On step number 7, you can configure step-up authentication. So the SAML challenge comes in at a configure frequency. Once you click on next, we'll move to the second part of the rule. All you can enable here is IPS. You can still modify the rule name and the rule order or sequence number in the list. At the top, we have the summary. This is going to give you a quick snip of what the rule configuration looks like as you go through it, through the configuration wizard. Cisco Secure Access Policy is a collection of both your internet rules and private rules, the rule defaults, and also the global settings. At the top of each rule, when you are configuring the rule, you have a summary section. Again, this is going to show a summary of what the rule is looking like when you're configuring it. You can edit a rule. This is very important. After you configure a rule, if you set it to allow the traffic, this action cannot be modified. If you need to create a rule for the same sources and destinations, but you want the rule to block the traffic, a new rule will have to be created. You can hover over these columns and they're going to show additional information about the rule without actually getting inside to view it. Okay, it's time for the secure private access demo. I will prepare the demo right now and start showing it shortly. Again, please let me know if the volume is too high, too low, and if any adjustments must be made. I'm about to start presenting.
Hi, Juan. I wanted to step in for a moment and indicate that it looks like the demo audio is not coming through fully. So we'll take a moment to pause and ensure the audio can be coming through successfully.
Thank you. Yeah, let me look into that really quickly.
Yes, thank you.
Hi, my name is Juan. Thank you for being here today. The objective of this demo is to show you how to protect your corporate private resources by policing the traffic with Cisco Secure Private Access, which works under a zero trust principle. We're going to review 3 different scenarios or flows in which Cisco will help you secure your private data. These flows are spoke to spoke communication using Cisco Secure Access Cloud as the hub. The second flow is remote access VPN to your private resources. This traffic will traverse the Secure Access Cloud. The last flow will showcase the new Cisco Secure Client Module, Zero Trust Access, also known as ZTA. In all the scenarios, it will be required to configure at least one IPsec tunnel. The rest of the requirements for the first flow are the configuration of those IPsec tunnels. We will register private resources in a dashboard. We create a secure access rule, test connectivity, and I'll show you how to review the logs in Activity Search. In the remote access VPN flow, after the tunnel is configured, I'll show you where to download and install Cisco Secure Client. We'll configure a VPN profile. Inside the VPN profile configuration, you need to call your IDP provider. In this case, I will use Azure as my SAML provider. We'll add private resources to your dashboard and configure a secure access rule. And we'll test connectivity and review Activity Search. In the last flow, after the tunnel is configured, I'll show you how to configure the policy-based routing, and I'll give you a quick introduction on CGNet. We'll download and install Cisco Secure Client, and you'll see the enrollment process from an end-user perspective. We will add private resources to your dashboard. We'll configure a secure access rule, we'll test connectivity, and review Activity Search. Let's get started. We'll begin by opening your favorite browser. Then navigating to login.soc.cisco.com. Once you log in, the first thing we need to do is configure two IPsec tunnels. To do that, we go to Connect and then Network Connections. Click on the second tab, Network Tunnel Groups. Here you can see the list of your existing IPsec tunnels. We're going to add one by clicking on Add on the far right side. We'll be met with a 4 steps wizard, and we need to fill out to register the tunnel. By clicking on the Help page, click on the left side under Supported IPsec Parameters. You're going to find a chart with all the IKA2 parameters that we supported. Everything in bold are the recommended settings. If you expand network tunnel configuration on the left side, you'll find a guide for all the devices that we officially support. If you scroll down, you'll see all the steps to configure the IPsec tunnel in your device. Because it is a spoke-to-spoke flow, we're going to register two IPsec tunnels, one for the ASA and another one for the CSR. Let's fill out the information of the ASA first. Provide a tunnel group name, and then select your region. I'm going to select Canada, and then select the device type. We'll do the ASA first. Click Next to continue. For the identity, we support email address or the public IP address of your IPsec device. I'm going to use the email address, and this is going to be my identity. Under the passphrase, copy and paste your pre-share key in these two boxes. Make sure it is between 16 and 64 characters long. It must enclose at least one uppercase letter, one lowercase letter, one number, and it should not include any special characters. Click on Next to continue. Under the routing section, you need to specify the network or networks that are behind your IPsec device. In my example, from my HQ office, I only have the 192.168.22 network. So this is the only network that I am going to add. Optionally, you can do dynamic routing, but this is an advanced feature and it's outside of the scope of the demo. Click on Save, and the last step is a summary of all the config. You're going to be given primary and secondary tunnel IDs, primary and secondary IP addresses, and the pre-share key. I will only configure one tunnel. Let me save all these settings in my notepad. Okay, we're done with the first tunnel. Just scroll down, you'll see the first tunnel here. It's currently disconnected. I'm going to register the second tunnel quickly. I will name this branch. Also in the Canada region, and this one is an ISR. Next. This is going to be the identity. My second tunnel is an iOS XE device. Copy and paste the pre-share key. And specify the network behind my CSR. It is the 192.168.86.0. I'm going to click on Save. This takes me again to the summary. I need to save information from here, the primary tunnel ID. I'll also save the primary IP address and the pre-share key. Click on Done. And let me bring the topology that we're going to use for this part of the demo. These two clouds connect the topologies to the internet. This edge device is my ASA. My corporate network is 192.168.22.0. This domain controller is the device that is going to host my private resources. On the right side, we have the branch office. Corporate network there is 192.168.86.0. And I'm going to perform the test from this Barney computer. It has a .10 IP. Let's go ahead and configure the actual tunnels. Let's do the ASA first. I have a script with all the configuration. I'm just going to copy and paste everything so we can move faster. I need to make sure that the ASA grabs the 22 local network and sends it to the 86 network through this tunnel. We're going to do that with a policy-based routing. Okay, this route map uses as a next hop 99.2. This is the adjacent IP to my tunnel interface IP address. The access list called my local network 22 and the remote network 192.168.86. And I need to add this route map to my inside interface. This is the last step. I can never remember these commands. There you go. I say BBR. Okay. Let's see if the tunnel is up. Okay, it's been up for over 100 seconds. Excellent. Now we move on to the second device, the branch router. I also have a script with all the configuration. I'm just going to quickly copy and paste it. Finally, the tunnel interface. Okay, this enables IPsec, and I can see the tunnel interface already changed state to up. Okay, the tunnel seems to be up and active. It's been up for 14 seconds. Great. When the traffic is sourced from my branch office, the 86 network, and is going to the corporate network 22, I need to tell my router to send the traffic through the tunnel. We're going to do that with a route map. This is the access list, and this is a route map. The access list has the 86 network as a source, the 22 network as a destination, and I'm using the 99.2 as the next hop IP address, which is the adjacent IP to my tunnel interface. The last step is to place this route map inside my inside interface. Let's do that. Okay, we're done with the tunnel configuration. This is all for the IPsec tunnel config in both devices. Make sure you save your configuration. It's time to add private resources. To do that, we go to resources and then private resources. This is a list of your private resources. We click on add on the far right side to add a new one. We need to fill all these boxes. Provide a resource name. I'm going to register my DNS server first. This is the IP address of my domain controller. And it's been promoted to a DNS server as well. That's the first resource. I'm going to add another one. I'll add my domain controller once again with a different name. If you add a resource with an FQDN, you'll be required to configure a DNS server for resolution. This, however, is not necessary for spoke-to-spoke communication. I'm going to register the IP address instead. And on the right side, I will open all the ports that I see necessary. This time, I will add 443 and 3389, HTTPS and RDP ports. This is all I need for now. So I'm going to click on Save. And I will also register my core switch. Again, provide the IP address of your internal resource and call the port that you want to open through the cloud. This should be all. Click on Save. Now we're ready to configure a secure private access rule. To do that, we go to Secure and then Access Policy. This is the list of all your existing rules. Before adding a new one, it is important to notice at the bottom, we have a default rule for all the private access, which is set to block, and this behavior cannot be modified. There's the other default rule for all the internet access, and this one you can modify and allow the traffic. This means that all the private traffic is blocked by default, so we need to explicitly allow it. Let's add a new private rule by clicking on Add Rule in the top right blue button and then Private Access. This first section is a summary of the rule configuration. We're at step number 1 of 2. First, let's provide a rule name. This rule order drop-down menu allows you to place the rule on a specific sequence number on your list of rules. This is the behavior, what you want the rule to do. I'm going to set it to allow. In the form box, you call your sources. You can browse through these elements and find what you need to call as a source. You can use the keyword at the top as a search. Optionally, you can click on this icon and use the search assistant at the top. I'm going to find my tunnel. Now I'm going to select the branch as the source of the traffic and click on Done. The next box is the destinations. This is where I call all my private resources. I'm going to expand it by clicking on this icon. In the search box, I'm going to use a keyword that will help me find all my destinations. My core switch, my domain controller, and the DNS. Click on Done. Click on Next to move on to the next step. The rule summary tells me I'm on step number 2 out of 2. And I can see the rule name. The action is set to allow, no security controls, and all my destinations. You can still change the rule name if you need to, and the sequence number. As per security, we can enable IPS, but this feature is outside of the scope of the demo. You can save. Okay, this is again my topology. The traffic is going to be sourced from this computer. Okay, as you can see, it's the .10 device. And it's using my 22.100, my domain controller, as the DNS server through the IPsec tunnel. First, I'm going to test the internal web page. Okay, great. The resource is reachable through the IPsec tunnel. I have a self-signed certificate in my domain controller. I can verify this is indeed my domain controller because of the certificate. Next, I'll try to log into my core switch. This is the IP address, and this traffic should traverse the tunnel. Okay, accept the key, and I can log in. Okay, let me show you the SPI. 192.168.22.254, which is the management IP. Great. I can also ping my domain controller by name. Okay, finally, let's go ahead and see everything we did in activity search. You go to monitor and then activity search. In this search bar at the top, I'm going to add the source IP of my branch PC. We can see my core switch connection port 22 and my internal website to my domain controller in port 433. This is all for the first part of the demo. I will reset the config, and when we come back, we're going to look into remote access VPN. First thing we need to do, as usual, is open up your favorite browser, go to login.sse.cisco.com, and we're going to register one IPsec tunnel. Hover over Connect, and then Network Connections. Click on the second tab, Network Tunnel Groups. Click on Add in the far right side. Set a tunnel name, region, and a type of device. Click on Next on the second part. Provide a tunnel name or identity. Copy and paste the passphrase in these two boxes. Click on Next. Under Routing, select the network or networks that are behind your IPsec device. In my case, I will add the 192.168.22.0/24. Click on Save when you're done. And step number 4 is a summary of all the config. You get the primary, secondary tunnel ID, data center IPs, and the pre-share key. I'm going to save the tunnel ID. The data center IP address, and the pre-share key. This is the topology we're going to use. On the left side, we have my corporate site. This is my edge device, is an ASA, corporate network 192.168.22, and the domain controller where I'm hosting the private resources. In the right side, we have this user, Gordon Freeman. He's a user connecting from home. His home network is 192.168.50, and the VPN adapter 172.16.32.0. Let's go ahead and configure the IPsec tunnel in the ASA. I'm going to copy and paste all the configuration that I have saved. Okay, that's it for the tunnel config. I'll tell the ASA to communicate the 22 network with the VPN pool network through the tunnel interface. This is the access list from my 22 local network to the VPN pool. This is the PBR. It matches the access list PBR. And the next hop IP address is the adjacent IP to my tunnel interface IP. Finally, I'll add this route map in my inside interface, and I'll be done with the config. Okay, it's been up for 96 seconds. Great. We're done with the ASA. Save the changes. I'll set the topology aside. We'll continue the configuration in a dashboard. You can download Cisco Secure Client from the dashboard itself. To do that, head over to Connect and then in User Connectivity. In the top right corner, you'll see a button that allows you to download the client. If you click on it, you'll be presented with different OSs. Just download the one that you need. I have already downloaded it, and I've extracted the zip file inside my testing PC. This is the folder with all the MSIs. Currently, I don't have any Cisco software installed. I'm going to install the VPN. Okay, here it is in the list. Okay, I'll set the client aside. Let's go back to the dashboard and continue with the configuration. Now let's click on Virtual Private Network. We need to configure a VPN pool first. First, select the region. I'm going to go with Canada and then add a name for this pool. This drop-down menu, you can call any existing DNS server. Otherwise, you can just add a new one by clicking on Add. Just fill the spaces at the bottom. We're going to use this one. An IP address of this network range will be used when the AnyConnect network adapter is enabled. The management pool functionality is outside of the scope of this demo, but we need to provide a network space here as well. Finally, in this drop-down menu, select your authentication server. The functionality and configuration of the AAA server is outside of the scope of the demo. Once you have the pool ready, go back to VPN profiles and let's create a new one. First, provide a VPN profile name. Provide a display name, a default domain. This drop-down menu called the DNS server, you want to inject to the AnyConnect network adapter. I'm going to go with IPsec. Posture is optional but highly recommended. For simplicity, we're not going to configure it. Click on Next. Step number 2 in the wizard is the authentication piece. It pre-selects SAML as the method of authentication, and I'm going to use that method. We need to integrate an IDP provider with this VPN profile. I'm going to use Azure AD. I have already created a enterprise application for this demo. This is it. In the first box, the basic SAML config needs to be updated. I can update it by feeding the metadata from the secure access dashboard. So I'm just going to download it. There it is. I'm going to go back to Azure and I am going to upload the XML data I just downloaded. Okay, successfully uploaded. Save it. And now that it's saved, I can scroll down and download the metadata from Azure. And I need to fit that to my remote access VPN configuration in the dashboard. Let's go back to the secure access dashboard and upload the metadata from Azure. After the metadata exchange is done, the SAML integration is completed. You can click on Next. This is the split tunneling mode. By default, this is going to use tunnel all config, where all the traffic is going to go to the secure access cloud, except these domains. Anything you add in this section will be excluded from the tunnel. I'm going to change the way the remote access VPN tunnel works. I'm going to bypass everything by default, and only the domains that I add to the list will be sent through the tunnel. My corporate network is the 22.0/24, so this is the only network that I want to send through any connect tunnel. Click on Next. On step number 4, we can configure timers, client settings, and also certificate settings. I'm just going to leave everything as it is and click on Save to finish the configuration. Once you're done with the config, a profile URL will be created, and this is what the end users need to use to connect to the VPN using AnyConnect. Next, we're going to register some private resources. Go to Resources, Private Resources, and I'm going to add my domain controller. This is the IP address, and other ports, I'm going to choose any TCP and UDP, and I'm going to open 443.3389 for RDP, and also 53 for DNS. Scroll down, make sure the VPN connections check is enabled under endpoint connection methods. This will allow the remote access VPN users to interact with this internal resource. Let's add a second one, which is my core switch. This is the IP address, change to TCP, and I'm only opening port 22. Same as my domain controller, click on this checkbox, make sure the resource can be reached via the VPN users. Click on Save. Now let's go to Secure and Access Policies. It's time to create a secure access policy. You can add rule on the far right side, you can private access rule, provider rule name, change the sequence number if necessary, set the action to allow, call the user that is going to use the VPN. I'm going to call Gordon Freeman. Click on Done, And then let's go to Add Destinations. This is where we are calling our private resources. Use any keyword that will help you find your resources. If you hover over these icons, you'll see that the resources are allowed to be contacted via remote access VPN users. On the second part of the rule, we can only enable IPS, but this feature is outside of the scope of this demo. Click on Save when we're done. You can drag and drop the rule to change its sequence number in the list. You can click on the rule name and expand all the configuration. Optionally, click on the ellipses and you can edit the rule from here or delete it if necessary. I am going to bring the computer that we'll use for testing. Grab the profile URL from the dashboard and paste it in this box and click on Connect. You should be redirected to your IDP provider. I have my credentials cached, so I'm just going to use those. Okay, the VPN session is established. If you click on the gear, you go to statistics, you can see the private IP address that was assigned to my network adapter and all the traffic that is traversing the remote access VPN connection or tunnel. Let's do some tests. I'll open an incognito page and browse to my private resources. The website I prepare my domain controller only displays this picture, so I can reach out internal resources. That's great. Now let's try RDP. Let's authenticate. Let's fix that. I'll make this user a member of the group. Okay, apply the changes and go back and test one more time. Okay, right. Okay, I'm not going to log in, but we made it to the login screen. Finally, I'll test SSH to my core switch. Great, this is the prompt of the key. Authenticate, and I am inside my core switch. This is the management SVI that you can see here in the topology. Let's see what we've done in the logs. Let's go to monitor and then activity search. We can use the username in the search box to find the VPN logs. This is the AD account. And I can see all the VPN activity. That's excellent. If you scroll to the right side, you'll see more information about the traffic. And further to the right, you can see the role that is handling all the traffic. Optionally, you can click on the ellipsis and then full details to view more information about every log. This concludes the second part of the demo. I will reset all the configuration, and when I come back, I'll guide you through the ZTA config. Okay, let's start by opening up your favorite browser. and navigate to login.ssc.cisco.com. We're going to register one IPsec tunnel. We do that in Connect and then Network Connections. Go to the second tab, Network Tunnel Groups. Click on Add on the far right side. Let's fill out all the information. Provide a network tunnel group name. Select a region. I will use Canada. And the type of device you will use for your IPsec tunnel. I am going to use an ASA. Click on Next. In the second part, provide a tunnel ID and a passphrase. I will use this as my tunnel identity and copy paste the pressure key. In the routing section, add the network or networks that will be behind your tunnel. I only have the 192.168.22 network. Oops. There you go. Click on Save to finish. And write down the tunnel ID along with the IP address of our data center. And the pressure key. This is the topology that we're using. On the left-hand side is my HQ space. My local network there is the 192.168.22.0. This is my domain controller that we're going to use for all the tests. In the far right side, this router simulates your home router. The user on the far right will be used to send traffic from the Zero Trust Access module. But how does that work? The Zero Trust Access module works very similar to the SWG module or the umbrella module. Let's say its requirements. So open a new tab in my browser and I'm going to search Cisco Secure Access Network Requirements. And I'll visit the first link. This part of the documentation, you have requirements for multiple functionalities of secure access. And the last one, if you expand it, you're going to find this network range. This is the carrier grade NAT range. Let's do a little bit of research. Let's visit the Wikipedia link. Okay, we're going to look at only the first 3 lines of the document. Carrier grade NAT is used by ISPs to NAT IPv4 networks. The reason behind this is based on the IPv4 address exhaustion. Let's look at the diagram for a second. If you're in a private network or at home, you're going to use IP addresses that fall under the RFC 1918, which are private IPs. When you want to go out to the internet, your edge device at home is going to NAT your private IP to a public IP, and then the traffic will be routable on the internet. Under a similar principle, your source IP can be NATed to an IP address inside the carrier grade NAT. This allows the ISP to be able to NAT your traffic again, if required. And that's all we need to know about carrier grade NAT for now. If you want to know more information, I invite you to look at this document and do a little bit more research. Now that we understand a little bit more about carrier grade NAT, when an end device with the ZTA client installed attempts to reach corporate resources, the traffic is redirected to the cloud. When the traffic hits the cloud, we're going to use a source IP address from this carrier grade NAT space. Then we will send it to your private space using the IPsec tunnel. In this case, your ASA. We have to tell the ASA to route the traffic back using the IPsec tunnel instead of the outside interface. Let's go ahead and configure all the IPsec parameters, the tunnel interface, and the route map. I have the script right here. I'm going to copy and paste all the config. Okay, that's all the IPsec parameters and the tunnel interface. Let's see if the tunnel is up. Okay, it just came up 1 second ago. Perfect. What we're missing is the route map. I'm going to add this access list and the route map. Let me show you what I did. This route map uses this PVR access list. The access list calls the 22 as the source of the traffic and the carrier grade NAT address space as the destination. In the route map, I'm using as the next hop the adjacent IP to the tunnel interface. And this route map needs to be placed in the inside interface. This is the last step. Let's do that. This should be all the tunnel configuration. Okay, I will dismiss the topology and we'll continue in the dashboard. Connection requests sourced from the ZTA client rely on the cloud being able to resolve the FQDN or the name of those resources. Let's register an internal DNS server. To do that, let's go to Connect and then User Connectivity. In the top right corner, click on Manage DNS Servers and add a DNS server here. We're going to use this later. Just provide a name and the actual IP address. We can communicate with this DNS server from the cloud via your IPsec tunnel. Now we need to register private resources. To do that, let's go to Resources and then Private Resources. Click on Add in the far right side. Provide a resource name. I'm going to add my domain controller. Add the URL or FQDN of your domain controller and open the necessary ports. I'm going to choose any TCP and open HTTPS RDP. When you add an FQDN for the private resource, it is required to configure a DNS server for the cloud to be able to resolve the name of the set resource. In this drop-down menu, I am going to call the DNS server that I just registered. Under Endpoint Connection Methods, make sure you select the Zero Trust Connection checkbox. This will allow this resource to be accessed from the ZTA client. And let's add a second resource. I'm going to add my core switch. Because I've added an IP address, selecting a DNS server is not necessary and is grayed out. Same as my domain controller, under Endpoint Connection Methods, make sure the Zero Trust Connections checkbox is enabled. And then click on Save. Now let's add a secure access rule. Click on Secure, then Access Policy. Let's click on Add Rule in the far right side, and then Private Rule. Under the summary, we're in step number 1. Out of 2, provide a rule name and the sequence number for this rule in the drop-down menu. The action can be left as allowed. Click on this icon to expand the search, and let's find the user that will send the traffic. In this case, Isaac Kleiner. Click on Done. For destinations, let's find the resources we just registered. Click on Done. Under Endpoint Requirements, a posture profile is automatically selected. This default posture profile scans for OS, firewall, endpoint security agent, and disk encryption in the end device. Because it is an advanced feature and is outside of the demo, I am going to turn it off. But this is something we highly suggest enabling. Click on Next. On the second section, IPS is the only configurable item here, but it's also outside of the scope. So I'm just going to save the rule. And the ellipse is on the right side, and then click on View to go over the configuration. You can edit the rule or delete it. If you need the client, you can get it from the dashboard. Just go to Connect and User Connectivity. There's a download button in the top right corner. It says Cisco Secure Client. If you click on it, you'll be presented with different OSs. Just select the one you need, and then you can install the client. I'm going to bring the machine that we're going to use for testing. Okay, let's install the Cisco Secure Client first, and then the ZTA module. These are all the contents of the zip file that you can download from the dashboard. Just like Umbrella or SWG, it is required to install the core VPN because it has dependencies that are needed for the other module to work. So I'm going to install AnyConnect VPN first. And now the ZTA module. Before we continue with the enrollment process, it is required that SAML is already integrated and configured globally in your dashboard. We can verify the SAML configuration under Connect, Users and Groups, and then click on Configuration Management in the top right corner. In the bottom part, the SSO authentication piece, this is a SAML instance that will be used to challenge users that are running Zero Trust client or clientless based. Let's bring the computer back. When I open the client, the GUI is going to notify that a one-time enrollment process is required. I have the credentials of this user cached. It is unlikely that your user is going to exist in two different dashboards, but if that is the case, you select the right dashboard. Then provide the credentials. Let me grab my authenticator. Okay, the enrollment is completed. Just open the client, go to the gear, Zero Trust Access tab. The first tab is Statistics. The second one is Advanced. All you can do here is unenroll the client. Under Configuration, you can just fetch the latest config from the dashboard and then a message history. Let's go ahead and test access to the resources. I'll open a private session and visit my domain controller private website. Okay, great. This is the website that I configure in my local domain controller. Close this. Let's try another resource. I'm going to RDP to my domain controller. I get the login prompt. This indicates there is connectivity. This user is not added to the remote access group. I'm going to close the RDP session. We didn't log in, but we get to the login page. That should tell us that there is connectivity. Finally, I'll perform an SSH session to our core switch. Okay, I'm inside my core switch. Great. This is the SBI. Right here. Perfect. I'm going to exit and dismiss the client and the topology. The last thing I want to show you is what the logs look like. So let's go to monitor and then activity search. In the search box, you can filter out by using the username, which is tested with. And here's all the activity. You can see ZTNA client-based connections as well as firewall events. If you click on the ellipses on the far right side and then full details, you get to see more information about all the events. If you scroll to the right side, you'll see the role that handled the traffic and the role action currently. Most of this traffic is allowed. Click on the ellipses. This is showing the role name, the destination. This is my domain controller private IP, and all the important details. And this is how the ZTA client works. Thank you so much for staying until the end. I hope you liked this demo and find it entertaining or educational. Hope to see you again in another webinar. Thank you for coming. See you next time.
Thank you, everybody, for staying with us. Okay, these are some of the secure access resources. The first link is our documentation page. The second link, you have a quick overview of the product, the service status portal to make sure all the components of the solution are up and running, the secure access data sheet with all the details about the product, and the release notes. Whenever we do upgrades, this is where you want to check. I want to thank you, everybody, for staying with us again with the demo. I apologize one more time for all the technical difficulties I've encountered earlier during the demo. We have a few minutes left. I believe we can use this time for Q&A. Thank you again for coming. I'm going to hand the microphone over to my colleague, Rachel.
Thank you, Juan. And as Juan had stated, this does conclude the presentation and demo section of today's webinar. However, we do have a few moments remaining. If you have any questions top of mind about today's session, please be sure to submit them into the Q&A section, and our team will be happy to get those answered before the session concludes. However, if you don't have any questions, you're more than welcome to stay on, review other questions that may have been submitted if they are of interest to you. Upon exiting today's session, you will see and receive a survey. We do welcome and want your feedback. This helps us to continuously improve, and we hope to see you at a future session. We really value your time, value your participation, and we also thank you for your patience throughout today's session. We understand it was a bit longer, but we also are glad to have you here. Thank you so much.